Hi, it's Mr. Baker here with another physics video. Today we're going to be looking at thermal power stations. Okay, so today we're going to be looking at thermal power stations and we're going to be answering this question: what are the advantages and disadvantages of thermal power stations? Okay, so here we have a diagram of a thermal power station. So thermal, the word there means something to do with heat energy. Power station is something that makes electricity, so it's a power station that uses heat energy somehow to make electricity. So we're going to have a little look at the process, although that's not so important as knowing the advantages and disadvantages of thermal power stations. But let's have a look at the process anyway. So thermal power station, we burn stuff, so we could be burning some kind of biofuel or some oil, some gas or some coal. So fossil fuels or biofuels are normally what we use in thermal power stations, and then we would set them on fire. Okay, so we are burning them, and by burning them, by the process of combustion, we are releasing the chemical store of energy, and we are radiating that energy as heat, and that is going into the thermal store of the water that's in the boiler. So that cylinder there with the blue stuff in there, that's the boiler. And that will boil, and as that boils it will turn into vapor or turn into steam, and so that turns into steam, and then that steam, after it's built up, will be released, and as it's released it will go through some pipes, past some turbines, and then back again. So it's kind of like this circular route that it goes round through the turbines, turns the turbines, and then you can see that some of the vapor will come out of these big cooling towers, and so the sort of the smoke that you can see sometimes if you go past a power station actually isn't smoke. Most of it is actually just water vapor coming out, and it's as the vapor is cooled back down again, condensed back down into water, so that we can reuse it in the power station. So the turbines are turning, and they will turn a generator. A generator is something that uses the kinetic energy into making into electrostatic store of energy. So that will make electricity, and then that electricity will go through the national grid until it gets to our homes and our businesses. And so that's how a thermal power station will work. And you can see that by burning stuff, what we're going to be doing is we're going to be releasing carbon dioxide. So fossil fuels and biofuels both release carbon dioxide. Now the difference is that as the carbon dioxide is released from the fossil fuels, more and more of that is released. So the fossil fuels have taken millions and millions of years to be made through a process of sort of squashing down dead matter and compressing it into the coal or the oil or the gas, which then we have to get to somehow by drilling down into it or by mining it. But because it's taken so long, that carbon dioxide just gets released into the atmosphere over time. Whereas carbon dioxide that's released by biofuels, we might say that that's carbon neutral, because the trees that we grow, or the plant life, whatever it is that we grow, that we use for our biofuels, don't take as long to grow, so that they actually absorb the carbon dioxide that's released in burning the biofuels, and then eventually the carbon dioxide goes to help produce more biofuels. So it's a bit of a cycle there. So that's why we might prefer to use biofuels over fossil fuels, because fossil fuels will be causing lots and lots of carbon dioxide, which will be going into the atmosphere, which will contribute to global warming and eventually climate change. Whereas biofuels, as long as we can get the balance right of growing the biofuels, growing the trees or whatever it might be that we're using to burn, then the balance of releasing that carbon dioxide and then making the fuels, it will actually mean that it's carbon neutral. So there's two ways that we can make electricity from thermal power stations. There is another way, and that's in a nuclear power station. Now a nuclear power station is slightly different in that there's a nuclear reaction, and it's called fission, the one that we actually can use at the moment. So in a nuclear power station, the fission will occur, which will then cause heat that heat will boil up the water again. The water will turn to steam. The steam will turn the turbines, which will turn the generator, which will make electricity, and then that will power our homes. Okay, so it's a similar process apart from the very start where it's nuclear fission instead of combustion that is causing the heat in the first place. Okay, so let's have a look at some of the advantages and disadvantages of using different types of thermal power station. So advantages might be that for thermal power stations, generally fuel is plentiful and cheap. Thermal power stations can be set up anywhere that you like, anywhere that you need them. The space required is less than most renewable resources. So renewable resources might take a large amount of space because they can't produce as much electricity for the same kind of space. Biomass power stations are carbon neutral, so that's an advantage, although obviously fossil fuel power stations aren't. Nuclear power stations do not produce carbon dioxide at all, apart from in their manufacture of actually making the power station and getting the nuclear fuels to the power station. Disadvantages are that carbon dioxide and other pollution is produced. A large water source is required to make steam, so we need to have that, so sometimes they are built next to the coast. They're not a particularly efficient way of making electricity. If you think about all of that heat that's produced, a lot of that heat just goes into heating up the atmosphere. So they're not particularly they are particularly inefficient. They're not particularly efficient. So they're not particularly efficient. Maintenance costs can be high. And disadvantage of nuclear power stations is that they require the waste to be stored for maybe thousands of years. So there's some advantages and disadvantages, and this is the kind of thing that you might be asked to analyse and to write longer answer questions and maybe give a balanced argument about why a certain situation should use certain types of power stations. Okay, so this is what you have done today. You should be able to describe what carbon neutral means. You should be able to describe how thermal power stations produce electricity and describe if different power stations are carbon neutral, and you should be able to describe some advantages and disadvantages of using different types of thermal power station. Okay, so we have looked at thermal power stations today, and we've looked at the advantages and disadvantages of those. There's lots of different ones. I suppose what the main type of disadvantage that we think of when we think of thermal power stations is because primarily we do use fossil fuels in them, is that they cause carbon dioxide. So because they produce carbon dioxide and that carbon dioxide then gets absorbed into the atmosphere, then we will have more global warming. Global warming will lead to climate change, and that's obviously a massive issue at the moment. So that's been all about thermal power stations. I've been Mr. Baker, and I will see you next time. Thanks very much.